going to talk about adding and subtracting polynomials. So adding and subtracting polynomials sounds a little bit more intense than it actually is. All of this is combining like terms. So we're going to revisit what combining like terms means, and then we'll look at it in an adding and subtracting form. So in order to simplify polynomials, we combine like terms. When we combine like terms, we want to make sure we are writing it in standard form. So we talked about that the other day. Standard form is largest exponent to smallest. So when we're looking to combine like terms, we're looking for the same variable and the same exponential power. That's what means it's like a like term. So what I like to do is kind of mark anything that I have with a symbol, and then anything that pairs with it with the same symbol. So I always start off with underlining, and I look, do I have any other y cubes? The answer is no, so I move on. And I'm going to mark this next term with like a little squiggly. And this is a y squared term, so I look to see if I have any other y squareds, and I do, so I mark it with the same symbol. And then I have just y to the first. It's the only of its kind. Now, when we combine like terms, all that means is we're adding the front number, the coefficient. Now here, the y to the cubed, there's nothing to combine with, so we just bring it down as is. It did not change. Here, we have the y squared, and this is a -8 and a +1. We want to remember there's always a 1 in front. So if I think about it, what's -8 plus 1? That's going to give me a -7 y squared. We don't do anything with the y squared. We're just counting how many of these we have. We have -7 y squareds. And then this last one, we just bring down the +2y. You can write in the first there if you want, but it's not necessary. So double check, is this in standard form? It is largest exponent to smallest. So example 2, same thing. I'm going to start off by marking my first term. It is a p squared. So I'm going to look for any other p squareds, and it looks like I have one right here. I also look for any others that are to the 5th, and I do have another to the 5th. So I have a couple like terms here as well. So I'm going to start off with the first one. Remember, this is a 1 in front. So 1 and -4. So what's 1 minus 4? That's -3. So I have -3p squared. Then I do my p to the 5th. So this is -4 plus 3. So remember, you're just adding the coefficient. So what's -4 plus 3? -1 p to the 5th. Now, I've combined like terms, but this is not in standard form. Standard form is largest exponent to the smallest, so I have to rewrite this. So that -1p to the 5th is going to come out in front, minus 3p squared is going next. So what I want you guys to do is pause the video, try this one on your own. So why don't you just try marking the like terms, double check that you have the correct like terms, and then try adding on your own, and then check that you added correctly. So go ahead and pause the video, try it on your own. Okay, so this first one here, this 5, that is called a constant. There's no variable like it, so what I'm going to do is look, I have another constant here, and I mark it with the same symbol. This is x squared. I scan through. I do have another x squared. This is x to the 3rd. Now, make sure to leave the symbol inside. We don't want to accidentally mark through the symbol. That's part of the 3. And then I have another x to the 3rd here. And then I have this lonely x. So now I'm going to combine. So the first one is 5 minus 1. That's pretty easy. 5 minus 1 is 4. Next, I have 3x squared minus 4x squared. So again, you're just adding the front. So what's 3 minus 4? -1x squared. Then my cubes. So I have a -3 and 4. What's a -3 plus 4, right? That's a +1. So I have +1x to the 3rd. And then I have this plus x that we didn't use. So that just comes down. Now, again, this is not in standard form, so I do need to rewrite it that way. So the 1x to the 3rd goes first, minus 1x squared, plus x, plus 4. Now, the reason we wrote this as a plus 4, there wasn't a symbol in front, but because it's positive, that means plus. Okay, save this one. We will do that in class. All right, now what does it mean to add polynomials? Adding polynomials is just another way of saying combining like terms, okay? But what it looks like is a little bit different. So it's just combining like terms, and we're going to learn two methods for these, okay? So when I'm looking at these, I kind of want to make sure you guys see this. This is what adding polynomials looks like. We have our different polynomials in parentheses and the plus sign between. So we're adding them together. But if you were to remove the parentheses, it looks exactly the same. If you took the parentheses away, it would look like one of these above. So all we're going to do first is write the polynomial as one large polynomial in standard form. And this is going to make our life a little bit easier for us, putting it in standard form. Then we're going to add the coefficients of like terms. And just make sure, just like above, when we are adding coefficients, we do not change the exponents. Remember, the exponents will never change when we combine them. The only thing that's changing is the front number. So first thing we're going to do here to make it a little bit easier to see is we are going to rewrite the whole thing without parentheses in standard form. So remember, standard form is largest exponent to smallest. So what I'm going to do is pull out the largest exponent. So if I look, the largest exponent is x to the third. So when I rewrite this, I'm going to write 17x cubed, and I like to cross them out so I kind of remember what I've rewritten and what needs to be rewritten still. I have a minus 8x cubed and a minus 11x cubed. Then I look for the next one. So the next exponent would be squared, but I don't see it. So now I have to the first. So that minus 4x to the first comes down, plus 5x to the first, and then that constant, that's a positive 6, so plus 6. Now what happens when we write this in order from standard, like largest exponent to smallest, it makes all of our like terms right next to each other. So if you look, all of these are x cubed. So instead of having to scan the problem for like terms, they're all right next to each other. So I still like to mark them, but it's just easier to see. Now, here, this is a little bit more complicated because we have three terms that are the same. So all you need to do is add them together, and you can use a calculator for this. So what's 17 minus 8 minus 11? If I were to add all of that together, that is going to give me a negative 2. So that's just negative 2x cubed. So remember, the exponents don't change, these stay cubed. Here we have a negative 4 plus 5. That one's a little bit easier. Negative 4 plus 5 is a 1, so 1x. And then nothing happened because there was nothing to combine this with, so it's just going to come down as plus 6. So same thing. Here we're going to add, but first we need to put them in standard form as one long expression, or basically just getting rid of the parentheses. So first thing I do is I look for the largest exponent, and I see the largest exponent is to the fourth. So I'm going to write 9x to the fourth, cross it out. And then if I look here, I have another. So I'm going to write minus 9x to the fourth, and then cross it out. Next, I have a squared. So we didn't have anything cubed, but I'm going to bring down the squared next. So 3x squared. Then I have the 5x. Then I have the minus 24, the constant, and another constant of positive 19. So everything's rewritten in standard form. And if I look, I have like terms here. This does not have a like term. This does not have a like term, but these are like terms. So here, 9 minus 9, that is going to give me a 0. So it technically cancels out. Like if you want, you can write 0x to the fourth, but anything times 0 is 0, so it goes away. This has nothing to combine with, so it comes down. 5x has nothing to combine with, so it comes down. And then we have negative 24 plus 19. Again, if you need a calculator, just use that. That is going to give us minus 5. And we see that it is in standard form. Okay, so what I want you guys to do is pause the video, try this one on your own, and then play the video and see how you did. Okay, so go ahead and pause, try on your own. Okay, so same thing, I'm going to go through and write in standard form. So I have a 3k to the fourth, And if I look here, another 3k to the fourth. Then I look, I have cubed next, so minus 2k cubed and a plus 2k cubed. Then I have an 8k and I have a negative 2k. So everything is written out in standard form. I'm going to look at my like terms. So I see I have a set of like terms here. I have a set here, and I have a set here. So in order to combine like terms, we just add the coefficients and just make sure, again, we're not changing the exponents. So 3 plus 3 is 6, so 6k to the fourth. Negative 2 plus 2 is 0, so remember that cancels out just like the one we did here. And then 8k minus 2k is going to give me 6k. So that is my final answer, and I am done. So we're going to save number 4 for class, and we're going to save vertical method for class as well. So we are done with adding, and we are going to flip over to subtraction. So subtraction is a little bit different. If you were to look between the symbols, we see a negative right here, so that's how we know it's subtraction. And we just have one extra step before we combine like terms. So all the extra step is we have to distribute the negative sign to everything behind it before we then write in standard form. Now, what we need to remember is when we distributing a negative is the same thing as multiplying. That's what distribution is. Multiplying by a negative 1. So what that does is it changes the sign of each term behind it. Once we do that, it's all the same. We're just going to write in standard form and then combine like terms by adding the coefficients. And just remember, do not change the exponent. That's the biggest rule here. Do not change any of the exponents. We're only adding the front. So first thing I need to do is distribute the negative. I'm multiplying by a negative 1. So what that does, negative times negative gives me a positive now 13x to the fourth. Negative times negative, positive 3x squared. Negative times positive, this now becomes negative 2x. Negative times negative, positive 17. Then I'm going to bring all of this one down. Now, the reason why this one does not change is because technically there is a 1 in front, but it is a positive. And if you were to distribute a positive, it doesn't change the sign of anything. So this front polynomial, nothing happens to it. So we just rewrite it into one big line. So I have 8x to the fourth minus 3x squared minus 11x minus 3. And now I have one long polynomial, but I want to put it in standard form to make my life a little bit easier to combine. So largest exponent, just like before, that is 8x to the fourth. Cross it out. Then I look, I have positive 13x to the fourth. Cross it out. Next is squared, so minus 3x squared plus 3x squared. Then I have a negative 11x, a minus 2x, minus 3, plus 17. So again, same thing as the front. All we did was distribute first, and then this is just like the very front when we added. So if I look, I have like terms here, like terms here, like terms here, and like terms here. So all I have to do is add their front numbers. So 8 plus 13, that's going to give me 21x to the fourth. So 21x to the fourth. Negative 3, positive 3 is 0, so it cancels out. Negative 11 and negative 2 is a negative 13x. Negative 3, positive 17 added together is a positive 14. So this is my final answer, 21x to the fourth minus 13x plus 14. So this next one is a little bit bigger because we have multiple polynomials. So what we have to be careful of is looking at what is between them. So we have a minus sign here and a minus sign here. So what that means is I need to distribute that negative to this polynomial, and then this negative is going to distribute to this one. So remember, all distributing a negative does is change the sign. So for this one, negative times positive gives me negative 2x. Negative times positive, negative 8x to the fourth. Negative times negative, positive 1. And that negative was only distributed to this one directly behind it. This negative is getting distributed to the one directly behind it. Negative times positive, negative 6x cubed. Negative times negative, positive 7x. This one didn't have anything in front of it, so this is going to stay exactly the same. So I have 4x cubed minus 4x squared minus 2x. So put into standard form, I have a fourth, that is my largest one, so I'm going to write that out in front first. So minus 8x to the fourth, cross it out. Then I have cubed, so 4x cubed, and another x cubed. I have a squared, so minus 4x squared. And I do not have any other squareds. So then I move on to my ones, right, to the first. So I have a minus 2x, another minus 2x, a plus 7x, and then I have my lonely constant here of plus 1. So when we get these larger problems, the biggest thing is to just make sure you write very neatly with enough space, because it can get a little confusing with how many there are. So we just want to make sure our handwriting is neat to keep track of everything. And then all I'm going to do is combine. So this has nothing to combine with. Like terms are here. This has nothing to combine with. And then these are like terms, nothing to combine with. So this negative 8x to the fourth is going to come down. Here it's just 4 minus 2. That's negative 2x cubed minus 4x squared minus 2x plus 7. So again, all of those get added. You can do that in your calculator if you want, right? So all of this will give me a positive 3x, and then that plus 1 comes down. And that's it. So next, I want you guys to pause, and you're going to try this one on your own and then check to make sure you've got it right. So go ahead and pause, try number 7. Okay, so this negative here needs to be distributed. So negative times positive is a negative 4x. Negative times negative is a positive 6x to the fourth. Negative times positive, negative 6. This had nothing in front, so it comes down as is, 8x minus 3x to the fourth. Now I need to rewrite into standard form. So my largest exponent is to the fourth. So minus 3x to the fourth. I have plus 6x to the fourth. I have an 8x, a minus 4x, and a minus 6. These are like terms. These are like terms. And then I just add the front numbers. So negative 3 plus 6 is a positive 3x to the fourth. Positive 8, negative 4, that is a positive 4x. And then that minus 6 had nothing to combine with, so it comes down as minus 6. Okay, and then we're just going to leave the rest for in class the next day. So this is it. If you want, you could try this one on your own, but it is a little tricky, so we are going to do this one in class together.